In this video, we're going to have a look at how you can determine the focal length of a converging lens by measuring the object distance and the image distance. In order to do that, we're going to make use of the lens formula, which is 1 over f is equal to 1 over u plus 1 over v. Now we're going to look at what those letters mean in just a second. First, we're going to look at the apparatus that's required, how we set that apparatus up, how we collect the data. Then we will look at plotting the appropriate graph and determining from that graph what the focal length of our lens is. So looking at the apparatus here, what we have first of all is a lamp, and the lamp is our light source. In front of the lamp we have our object. In this case, the object is a small washer with a cross in the middle. Next, we have our lens. This is a converging lens, which is also known as a convex lens. And then we have our screen. This is where the image is going to be formed. We also have our ruler, which will allow us to take the appropriate measurements. So what are the measurements that we need for this? We're trying to figure out the focal length, which from the equation is f. So that means we need to measure u and v. So let's start with u. U is the distance between the object and the centre of the lens. So I'm drawing dashed lines just to represent that. And the distance between the two is what we call u. V is what's called the image distance, and it's the distance between the lens and the image, and we call that v. So we begin by moving the lens towards the object, making that distance 15 centimetres. So u is equal to 15 centimetres. In our table we'll actually record it in metres, so that will be 0.150. Next, adjust the screen until you get a sharp, clear image formed on the screen. It can be tricky to see, which is why it's best to do this experiment whenever there are low light levels. And don't be afraid to move it backwards and forwards and adjust it as much as necessary until you get that clear image. Once you have that, record both your values for u and v into your table of results. Then you can go about changing the object distance, increasing it now to 20 centimetres. Now we'll have a look at the data collected and see how we take that data and determine the focal length of this lens. Now that we have a range of values for u and v, we can now begin to work out what the focal length of this lens is. So let's remind ourselves of the equation. 1 over f is equal to 1 over u plus 1 over v. So there's two methods that we can use to find f. We can use a graphical method, or we can use a calculation. First of all, we're going to look at the graphical method. In order to use the graph, we need to plot a straight line graph, which means we'll need to manipulate our equation somewhat so that we can figure out what value we should plot on the x-axis, what we should plot on the y-axis that would result in a straight line. So first I'm going to bring the 1 over u to the other side where it will become a minus. So we have minus 1 over u plus 1 over f is equal to 1 over v. Next, I am going to actually split up the minus 1 over u because that's the same as minus 1 multiplied by 1 over u plus 1 over f is equal to 1 over v. Now I want to match this up to y equals mx plus c. So the last thing I'm going to do is I'm just going to switch sides so that I have 1 over v is equal to minus 1 times 1 over u plus 1 over f. Now we can match this up to the standard equation for a straight line, which is y is equal to mx plus c. By looking at this, what we can see then is that if we were to plot 1 over v on the y-axis and 1 over u on the x-axis? Well, first of all, we would have a gradient of -1, so we would expect a negative slope. But if we then look at the y-intercept, that will be equal to 1 over f. So that's what we're going to do next, is we're going to plot a graph of those values. Of course, that means we need to figure out what those values are first. We need to work out 1 over v and 1 over u. So in our table here, the next column is going to be 1 over u. Now, since we're doing 1 over u, that means we also need to do 1 over the unit. So that's 1 over meters, which is m to the -1. We also need to work out 1 over v. Again, our unit is m to the -1. So now you can pause the video and go ahead and work out what each of the values are for 1 over u and 1 over v. And remember to give all of your values to 3 significant figures. Once you have your values calculated, the next step is to plot the graph. 1 over v on the y-axis, 1 over u on the x-axis. It should look something similar to this, where the points are linear, they're following a straight line, and that is of a negative slope. So the next step now would be to add in the line of best fit. The line of best fit should go through as many of the points as possible. You want to make sure that you have an even distribution of points on either side. As we can see from our equation, where we mapped out the lens equation to y equals mx plus c, we can now find the focal length of this lens by working out what the y-intercept is. If we look at the y-intercept here, this value is equal to 1 over f. So what we need to do is take the reciprocal of this value, and that will give us the focal length. Now, in fact, if we actually were to look at the intercept on the x-axis, that would also give us the value. Because just by looking at the equation, 1 over f is equal to 1 over u plus 1 over v. Well, if u is 0, then 1 over v is equal to 1 over f. But likewise, if v is 0, then 1 over u is equal to 1 over f. So in either case, reading the axes at either point will actually give you the value of 1 over f, and hence from that you can work out what the focal length is. For this set of data, you should find that f is equal to 0.1 meters, which is 10 centimeters. To summarise this experiment, there's 4 key areas that we want to look at. First of all, the diagram. In an exam, you could be asked to replicate this diagram, and you need to make sure that you add on labels. Not only should you label the apparatus, but you should label any key distances. So, for example, you need to make sure that you label exactly where u and v are. We have 2 key measurements that we take. We measure u, which is the distance between the object and the lens, and we measure v, which is the distance between the image and the lens. Both of those are measured using a ruler, and it's really important that you include the piece of apparatus that you are using to take your measurements. For the method, there's 2 key things that you need to mention. First of all, we need to mention the fact that you're adjusting u and v in order to get a sharp image. And then once you've done that, you change the object distance and you repeat that process so that you have a range of values for u and v, each one creating a sharp image. Finally then, analysis. So how do we get our value of f from the data that we collected? So we can either talk about the graph, which is plotting 1 over v versus 1 over u, and in that instance either intercept would give you 1 over f, or it's also equally valid to discuss calculating the value for f using 1 over u plus 1 over v equals 1 over f, so using that lens formula. What a lot of people forget though is that if you do use the calculation, you must average your value that you've worked out for each set. What I recommend you do next is pause the video at this point and make a copy of what's on the screen in your own notes. Everything you see on here has been taken directly from a CCEA mark scheme. They usually award 2 marks for each of the highlighted sections. So it really is worth making sure that you understand this practical inside out. So that's it. That's the lens formula. That's working out the focal length of a lens by using the object distance and the image distance. From the beginning where we set up the experiment, collected the data, right through to plotting the graph and determining a value for the focal length. Hope you find that useful.